702 and Cape Talk.
The Naked Scientist.
Chris, good morning.
Morning, Googs.
And how are we this week?
In fine form, and I hope you're the same.
Very good. So this is an interesting one. Skin cells apparently can remember previous injuries. How do they do that?
Yep, your skin has a memory. And actually, this is a discovery. It's from New York. It's just come out in the journal Nature. And Shruti Naik is the author of the paper, in which they made small injuries in skin and then showed that if you injure the same patch of skin up to maybe 6 months later, it heals up 2.5 times faster than a previously uninjured bit of skin being injured for the first time, or an individual that's never had an injury. And initially they thought, well, maybe the immune system is remembering something in that patch of skin. Maybe there are cells there that have come in during the initial injury and they're making this happen. But they repeated these experiments in mice that can't make certain components of their immune system, and they got exactly the same results. So looking at the stem cells in the skin, what this group found is that the stem cells reconfigure themselves genetically so that they have a genetic memory of the previous injury, enabling them to leap into action much more quickly. And the way they do that is that they unwind their genetic structure. They have very tightly wound up genetic information in a form called chromatin. And some genes are unwound and left permanently exposed. It's like flipping the cap off of a can so that you can go in and immediately open it. And this leaves those genes primed, ready to turn on if there is another problem in the future. And you might say, oh, that's great because it means your skin can heal up and react and respond very rapidly. And that's true. But actually, it also has a downside because there are many skin conditions. These include eczema, otherwise known as atopic dermatitis. They include psoriasis and even forms of skin cancer, because you've got a situation here where cells are being encouraged to grow faster and more abundantly than they would do normally. And all of these sorts of things are potentially involved in cancers, not just in the skin either, maybe in other organs if the same thing's happening. So what this shows us is there might be a new way to intervene and treat certain skin diseases which are caused by an overreaction of the skin to an injury. And so that's very exciting.
And the other thing that this study has shown is the ability of the skin to what do they call it? To guard against the same thing happening again, and they called it so anticipating subsequent damage, and then the body's able to deal with it a lot quicker. But with if the stressor changes its form, does the skin have the same ability to preempt some kind of damage?
Yeah, because actually they do that in the paper. What they do in their Nature paper is that they trigger the first type of damage with a drug, and then they come back and they actually make wounds in the skin to make a second injury. And in that way, they're doing exactly the experiment you proposed, that the way in which the skin is being damaged is different the second time, but the response, a more rapid healing and growth of cells, is more dramatic the second time because the cells have remembered, in inverted commas, that they were injured before. So it is important because there are lots of examples. There's also the formation of what we call keloids, and black skin is more prone to getting keloid formation than white skin. And this is where you have an overgrowth of the skin in response to an injury, which can produce an unsightly scar. Now, it might well be that this sort of thing is underpinning those sorts of skin conditions. And so understanding more about how this works and working out how to stop it will give us an inroad into how to deal with a whole raft of related skin conditions in future. It's very exciting.
Someone asking the question, which kind of relates, I guess, to skin conditions, but saying, what is the association of shingles, the chicken pox, and I think they were also asking about herpes.
Yep.
And they were saying, I think one gets chicken pox once, but shingles seems to be recurring once a year or so.
Well, these are all members of the herpes virus family. These viruses are adapted to, once you have been infected with them, they remain in your body for the rest of your life, and they hide as a piece of genetic information that can periodically come back to life and produce new viruses. You only get chickenpox once. This virus, this herpes virus, it's also known as the varicella zoster virus, infects usually via the respiratory route, goes into your lungs. It then spreads through the bloodstream to the skin, and when it's in the skin, it produces blisters, and those blisters amplify the amount of virus that's around, and it also infects nerve endings. Once it's in the nerves, it stays there, and periodically, in response to low sort of immune response, or if you're feeling down, or if you're not very well, it reactivates in that particular patch of skin. New viruses are made, exported to the skin surface, and you get shingles. So shingles is the same virus that caused chickenpox, but unlike chickenpox, which affects your whole body, shingles is restricted to just one zone of the skin. The good news is that it won't spread anywhere else on your body. The bad news is you can give shingles virus, because it's chickenpox virus, to somebody else, and if they've never had chickenpox, they will get chickenpox from your shingles rash. It can also be very painful, and it can produce a condition called post-herpetic neuralgia, which can produce long-term tingling, itching and pain sensations in the patch of affected skin. There are drugs that can control it. If you take the drug acyclovir, which is an anti-herpes drug, as soon as you see the manifestations starting, you can sometimes reduce the intensity and the severity, and there are other things that can be added to the skin to reduce the pain and the risk of post-herpetic neuralgia. These include drugs that contain the chemical capsaicin, which is the same stuff you find in chili peppers. So you're sort of rubbing chili on your arm, but it does work.
We've got David in Fishhook with the question. David, good morning.
Good morning. Hi.
Yes, David, your question.
Yes, hello, Chris.
Hi, David.
Hello, hi there. It might sound crazy, but there's a lot of intelligent people who are questioning the shape of the Earth. Have you heard of that?
I have, yeah.
Yes. No. The main thing is that to really end this debate, what I'm looking for is some kind of statistics that measure the curvature. You know, if there are bridges that have used the curvature, or because there are certain things that deceive people, like nominal visibility and geographical visibility, where people think the ship has gone over the horizon. They get out their binoculars, they see the ship reappear, so they start presuming that the Earth is flat. And there's people who've done experiments with laser beams, and apparently the laser beam has remained constant. And this is something that is really stumping very intelligent human beings. They're not just... that is my question is if there's a way to find this curvature measurements.
Yeah, we're very good at this, David, and we've got loads and loads of evidence the Earth is not flat. And the people who say the Earth is flat are, I don't want to insult them, but they're mad. And it's completely nuts, all this. Just look at the moon in the sky. What shape is it? The moon in the sky is not a flat dish, is it? The moon in the sky is a nice round sphere. And if you look at the satellites that go round the Earth, how do you explain a satellite going round the Earth in a, say, circumpolar orbit, north to south pole, so the Earth rotates inside the orbit of that satellite? How on earth is it doing that if the Earth is flat? I mean, come on. I don't know why people in the 21st century are still coming out with this drivel. Aristarchus, who was a famous Greek philosopher in 230 BC, actually first came up with a heliocentric model of the solar system and said, sun, planets going round sun, sun's a ball in the sky. You know, people 2,000 years ago weren't struggling with this. I find it amazing that people are still coming up with this in the year 2017. I don't mean that in an offensive way, but I just, my mind boggles. It really does. But there is no question the Earth is not flat. The Earth is a round ball, give or take, and things go round the Earth in space, and we can go round the Earth in space. We can look at it, and we can tell you it is not flat.
Yes, no, well, I completely agree with you. I watch the stars, and it makes, there's absolutely nothing that makes it as the evidence for the flat Earth. The only thing that stumps me with these intelligent people is the measurements that they come up with.
Well, the same measurements are able to put spacecraft on planets billions of kilometres away. And if those measurements were so hard to make, I do not understand how someone can land a space probe on a comet or land a space probe on a distant moon of a distant planet and make all of the measurements they do and somehow be labouring under the false apprehension that our planet's round when in fact it's flat. It is not. The Earth is round, and there's no disparity in the measurements. They've been made very precisely. I suspect you're a victim of what we call fake news, where people just tell a good story because it's a good story to tell, and actually it's not underpinned by any decently solid facts.
Thank you very much for that question, David and Fishhook. Puluso in Orange Grove, good morning.
Hi, Goops.
Yes.
Hi, Chris.
Hi.
I want to find out why do some stains last permanently or are persistent? I'm talking about some food like mulberry and some known food like vegetables, like butternut. Why is it the chemical or is it the color of the fruit?
So like mangoes, once you get mango on
Yes.
your clothes, that's pretty much it for your eyes.
Yes.
People
Why is
say
it?
one of the strongest forces in the universe is the attraction between a white shirt and tomato sauce. I think I'm inclined to agree with them. The reason is that there are chemicals which are in the fruits. Fruits make these chemicals to give them colour. They include things like carotenoids, hence carrots are called carrots because they contain carotenoids. They're orange colours. That's where we get the name from. There are also anthocyanins and that kind of thing. They're the purple chemicals that make beetroots a purple colour. The plants make these various pigments and they give the plant colour. Those pigments can be quite stable, the molecules. They will also bind with great vigour to the textiles that our clothes are made from. So if you get them onto the textile, then they can actually insert themselves with a chemical bond onto the fabric. They can also sometimes get in amongst the fabric, and it's very difficult to dislodge them, so they just impart colour. And as a result, they're very, very difficult to remove. Some stains are easier to remove, but they're not easy to remove with water. Now, you mentioned butter. Butter's a good example of this. Because butter is fat, it's oil, if you wash your clothes only with water, then because oil and water don't mix very well, then the water struggles to dislodge the butter from the fabric, so you still get a stain there. And this is where biological washing powder comes in. Washing powders that are dubbed biological contain enzymes, which are small chemical entities which act as catalysts, capable of breaking down things or making chemical reactions happen far faster and at far lower temperatures than they otherwise would. The manufacturers of biological washing powder have found enzymes which they add to their washing powder, and these include fat-degrading enzymes called lipases. When you wash your clothes with these particular washing powders, the lipases attack the butter or the fat or the oil or whatever else has got into the clothing and your body's own grease as well, and they break it down and they make it become soluble in water so it can then be dislodged or washed away. And some of these other very good stain-removing detergents, some of them work in a similar way. They can break down some of the molecules that give colour to stain molecules. They also can get between the stain and the clothing and prise the dye molecule off of your clothing in order to get rid of the stain. You have to be a bit cautious, of course, because the same thing can happen to the colour of the clothing. So you can end up decolorising your clothing, but sometimes you have to do that.
Wow. Thank you.
Pleasure.
Thank you for your question.
702 and Cape Talk.
The Naked Scientist.
Chris, there's a question here about why do humans, I guess because we don't know what other animals, how they respond to this, but why is it that it seems you get less sober a lot faster when drinking through a straw?
I don't think there's any evidence for that. I thought you were going to say, does a fizzy wine versus a non-fizzy beverage make you drunk more quickly? And that's true. There is
Really?
evidence that if you drink fizzy booze, you will get drunk more rapidly than if you drink non-fizzy booze. And this experiment has been done in a limited way. Researchers in London did this experiment. They took some champagne. They took identical champagne, made some of it flat by leaving the cap off of it for a period of time. So in other words, you had the same beverage and they were satisfied the alcohol concentration was the same. But when fed to individuals, the people who drank the fizzy version did appear to become drunk more rapidly. There's also evidence that if you make your Bacardi and Coke with with a sugary Coke versus Diet Coke, you will become drunk more quickly if you have it with Diet Coke. Now, in both cases, it's probably to do with gastric emptying. When you put things into your stomach, the stomach acts as a sort of hopper, a holding bay for what you put into it. It releases food and calories at a rate that it thinks the small intestine can process that. If you take a heavy sugar load into your stomach, then the stomach slows down the rate at which it releases the contents into the small intestine, and therefore the alcohol, although some of it can absorb through the wall of the stomach, it's much more efficiently absorbed through the wall of the intestine. So the faster you let the food and drink exit from the stomach, the more drunk you're going to become more quickly. So if you have a heavy sugar burden, it will slow that down a little bit, and therefore you won't become drunk quite so quickly. But with the diet version, the stomach says, well, no sugar in here, not many calories, lets it all go, and it all gets absorbed quite quickly. With the CO2 fizz, probably because the CO2 may do something to the rate of gastric emptying. It may speed that process up, which is why you become drunk a bit faster under those circumstances. But drinking through a straw, I'm not convinced that there's strong, compelling evidence that this would make you become any drunker any faster, unless just drinking through the straw makes you drink the drink faster. And if you drink the drink faster, you're taking more alcohol in less time, so there's a higher rate of alcohol delivery into your body, therefore a potentially bigger spike in blood alcohol concentration, and therefore you might become a bit drunker.
We've got Fana in Waterfalls with a question. Fana, good morning.
Morning. Hi, Chris. Chris, when I run a shower, it might take some time for the water to heat up. And often, in fact, invariably, I feel that I can actually hear the point at which the water starts getting hotter because it just sounds very different. The cold water sounds like it falls harder than the soft water, than the hot water. What's that all about?
It's true. There are probably several aspects to this. One of them is that when you turn the shower on, the rubber washer, which is in the tap and stops the water coming through until you undo the tap, as the water goes past it, warm water is going to make that swell up a bit, and therefore the rate of flow of water will change slightly as the rubber swells up and expands. That will happen to the cold tap as well a bit, but that may change the flow rate, which might produce a sound difference that you're hearing. Probably the more dominant effect is that warm or hot water is less viscous or sticky than cold water. If it's less sticky, because the particles of water have more energy and are therefore clinging to each other slightly less hard, then the water is going to separate into smaller droplets more easily than when it's cold. And this means when it issues from the shower head and splashes onto the floor of the shower, it's going to fragment into more small particles and make a higher pitched note than when it's coming out in a more viscous state. So therefore you probably will hear the note of the shower change when the hot water comes through, and you'll hear a higher sound as the warm water starts to come through. And I suspect that's what you're picking up on.
Thank you very much.
Thank you very much for your question, Fana. Pamela in Gardens with a question about cats. Pamela, good morning.
Good morning. Good morning, Chris. Could you please explain a cat's amazing ability to jump from one place to another? It's never the same distance, probably various points. And I can see on my cat's face that he is measuring that distance in his mind, shows on his face and in his eyes, and he never misses. No matter what the distance, he will land exactly where he planned to land. Thank you, Chris.
Hello, Pamela. Yeah, animals are very good at this because their life depends on it. And if the cat misjudges a jump from one rooftop to another, then it's curtains for the cat. So there's a pretty strong motivation for the cat to get it right. But it's not just cats that are really good at doing this. People have done studies on dogs, for example. One person published quite a famous paper now. It's notorious because it caught everyone's attention. This gentleman was walking along beside some water, throwing stones into the water for his dog to jump in and catch, or throwing a stick in. And he noticed that rather than the dog entering the water wherever the dog was standing to swim to the stick, the dog would run along the shore the right distance and then enter the water where the amount of time he would spend swimming for the stick was at a minimum. In other words, the dog knew that running along the beach was easier and faster than swimming, and so it was actually doing quite complex trigonometry in its head to work out what the shortest course through the water would be to retrieve the stick or the stone. So, in other words, animals have in their minds and so do we, a very complicated neurological circuit in order to do these sorts of visually guided movements and do them very fast and perform them very accurately. And this is millions of years of evolution. We've all become very good at anticipating where we want to put ourselves in three-dimensional space, and they're making the right movements at the right rate and with the right strength in order to arrive at the right place. Otherwise, we get very badly injured.
Thank you, Chris.
Pleasure.
Thank you very much. That's Pamela in Gardens. And Chris, thank you very much. That's the chat with the Naked Scientist for this week.
Thank you, Cougs. Bye-bye.